Once again, good morning, everyone, students. I would invite Arun sir to start the session.
Thank you, ma'am.
Thank you, sir.
Good morning, everyone. Hello, students. Good morning.
Good morning, sir.
Hi, good morning, Vignesh. Yeah. So, have you seen the DPP which I sent yesterday in the afternoon? I've sent a set of problems. I mean, that was not for homework, but I've given you homework as well. Have you tried the homework? Have you done the 10-minute exercise? That file is to be solved now. The 7 problems, you'll solve it now. Sorry. All right, let's get started. So, let's look at the first problem in that. What is the first problem say? Uh, yeah, first problem says the motion of a body is given by the equation A is equal to 6 minus 3v, right? And then you have to check the correctness of the following results. Body starts from rest at t equal to 0. We need to talk about terminal speed, initial acceleration, how does speed vary with time, and speed at certain point time. All right. So let's see how do we do this. We've got acceleration as a function of velocity. Right? This is what the equation is. So I can write A is equal to dv by dt and integrate. Yeah, that's fine. But what is happening here? That we initially particle starts from rest. So initial velocity is 0. So there is an initial acceleration, because of which the particle will accelerate. All right, it's just same as our raindrop problem, G minus kV. All right, it's not a new problem, it's the same old problem. Only thing is we have got numbers here. Instead of symbols, we have got numbers here. We have done this problem yesterday. G minus kV we have done already. You remember G minus kV? Raindrop problem, you remember?
Yes, sir.
Okay, Ashita remembers, good. How about others?
Yeah, sir.
Okay, good.
Yes, sir.
Yes, sir.
All right. Thank you. Thanks for responding. And so I've got 6 minus 3v. So I've got an acceleration like this. This is acceleration versus velocity time graph. Velocity graph. This is 6. Slope is 3v. Where does it intersect the x-axis? What is the x-intercept? When acceleration is 0, I'll get some velocity, which is terminal velocity. That is what happens in raindrop problem, right? Velocity goes on increasing. For the drop, initial acceleration is 6, because of which there will be initial velocity is 0, there will be change in velocity, because of which there will be reduction in acceleration, but there is still an acceleration, there will be increase in velocity. Because there is an increase in velocity, there will be acceleration will reduce, reduction in acceleration, further increase in velocity, acceleration becomes 0. This velocity is terminal velocity. How do I get terminal velocity? I equate acceleration to 0. So 6 minus 3v equal to 0. V is equal to 2 meters per second. Is my terminal velocity. That's what in the graph as well I get. This is 2. This is 6, this is 2, this is origin. All right, this is what your scenario is. That's so first option says terminal speed is 2 meters per second. So is it correct? At Vt, my acceleration becomes 0. So I equate acceleration to 0. I get 6 minus 3 Vt equal to 0. So Vt is equal to 2 meters per second. So terminal velocity is 2 meters per second. So that's correct. Option A is correct. Option B, magnitude of initial acceleration is 6 meters per second square. Initial acceleration, that means at t equal to 0. At t equal to 0, my velocity is 0. So if I substitute v equal to 0 here, I'll get a is equal to 6. So that is also correct. How about the third one? speed varies with time as this much. That is what, for that, we got to integrate. So let's see how integrate and see what do we get. So I'll write this as dv by dt. So dv by 6 minus 3v is equal to dt. Right? I multiply by minus 3 on both sides. All right, I multiply with minus 3 on both sides. I integrate at t equal to 0, my velocity is 0. At t equal to t, velocity is v. So this is f dash x by fx. Log mod fx. Log mod 6 minus 3v. But because 6 minus 3v is always positive, I can remove this mod. I substitute limits 0 to v, and this is minus 3t. All right. Now I substitute v and then substitute 0. So what do you get? Is log to the base e. Log to the base e, 6 minus 3v by 6 is equal to minus 3t. Now I get 1 minus v by 2 is equal to e power minus 3t, which implies v is equal to 2 times of 1 minus e power minus 3t. So what does the function say over here? Yes, that's right. So option C is also right. All I did was integrate. I did just the math. Simple math, all right? I mean integration. Is it okay? Say yes or no.
Yeah, sir.
Okay, Vignesh is okay. Others? Are you all sleeping? Good morning. Okay, okay, fine. And let's look at the fourth option now. Speed is 1 when the acceleration is half the initial value. So when acceleration is half the initial value, what is the initial value of the acceleration? 6. So when it is 6 by 2, half the initial value is equal to 6 minus 3v naught. So I'll get, this is 3, 6 by 2 is 3. So 3v naught is equal to 3, v naught is equal to 1 meter per second. So that is also correct. Acceleration is half the initial value. What is the initial value of 6? That's what we got from the first option. Sorry, second option. So half the initial value is 3. 3 is equal to 6 minus 3v naught. I've got to find v naught. Speed of the particle when acceleration is half the initial value. So v naught is equal to 3 by 3, which is 1. All right. Now, if I were to find out at what time does it happen, how do I do? I substitute this 1 over here in this equation. V as a function of t. If I substitute 1 here, I'll get from this equation, I'll get time t. The instant at which acceleration is half the initial value, or velocity is 1 meter per second. All right. Okay. All right. So let's go for the next one. Yeah. Next one is velocity of the particle moving in the positive direction of the x-axis varies with v is equal to alpha root x, where alpha is a positive constant. Assuming that at moment t equal to 0, the particle was located at point x is equal to 0, find the time dependence of velocity and acceleration of the particle. the mean velocity of the particle averaged over the time the particle takes to cover first s meters of path. This is a good one. We have talked about average, but we have never applied average of a function. After basic math, we have not applied average of a function to any value or to any problem. So let's look at that over here. So would you like to try this problem? Have you tried any problem? Like they have given you two homework problems as well. Have you tried those problems, students? Have you tried that problem? Any problem have you tried? Two problems I gave you, two picks. You haven't tried. That's
No,
okay.
sir. No, sir.
Okay, you didn't get time to do.
No, sir. I didn't attend class yesterday.
Oh, why? Why didn't you attend?
I have a network problem, sir. From
Okay,
5 o'clock.
you could not listen to the recorded session then?
No, sir.
Okay, you don't have access yet, right?
Yes, sir.
All right, all right, all right. In that case, it's difficult. How about other students? Gayatri, Likita, Hasini, Bhavna. See, if you don't try, if I only solve the problems, that's of no use to you. All right, that's only a practice to me, which is of no use because I'm not going to write the exam. It is you who's going to write the exam, right? So it is very important that you think through whatever we are doing. You're supposed to think through, do the 10-minute exercise, and try a problem. Trying a problem is doesn't you don't have to sit and do the problem. In lunch or while eating, you can think about the problem. While walking towards the school, you can college, you can think about the problem. While in the bus, you can think about the problem. All right, that's what I mean to say. Preparation, let the preparation be 24/7. All right. Okay. I just want to repeat this fourth case. Acceleration is half the initial value. What is the initial value of the acceleration? 6. Half of that value would be 3. So using this equation, A is equal to 6 minus 3v. I get 3 is equal to 6 minus 3v naught. Let v naught be the speed at that instant. So 3v naught is equal to 3. V naught is equal to 1 meter per second. Nothing. I just got it from this equation. I substituted A is equal to A by A naught by 2. What is A naught? Initial acceleration, which is 6. 6 by 2. I substitute 3 is equal to 6 minus 3 V naught. I got V naught from there. The point was, if at all I want to get the time, how do I get the time? To get the time, I'll use this equation. Velocity, third equation, third option. Velocity as a function of time. Where I substitute velocity as 1, and 1 is equal to 2 into 1 minus e power minus 3t. I'll get t from this equation. All right. Is it clear now?
Okay, sir.
Okay. We'll look at the third question first. We'll go to third question, then come back to this question. Students are upsetting me. What's the point of sending you questions on WhatsApp? Oh, why do I take out time from my lunch hour and then do it? For your good, nah? And you don't try at all, you just leave the questions like that. You don't even read the questions. It's not good, nah? Is it good? Is what you're doing correct? It's demotivating. I mean, I lose motivation to do anything for you. Okay, everyone, you try this problem now. Which one?
Add one, sir.
No, do the last one, because last one also we have done it in the day before yesterday's class. I want you to do it right now. So yesterday I have not done any variable acceleration problems yesterday. So those who were present day before yesterday also can do all the problems today. Yesterday I have not done any problems on variable acceleration. I just did bit of relative velocity, right? So even if you missed yesterday's class, you can do yesterday's homework. Look at the last question. V naught minus kx. Velocity of the particle traveling along a straight line is V naught minus kx, where k is a constant and x is equal to 0 and t equal to 0. Determine the position and acceleration of the particle as a function of time. Students, we are aiming high. We are wanting that you crack Iit-Jee advanced. But it means definitely we'll crack, but we also want you to crack advanced exam. That is what we are working on. And you people are not serious. How much time does it take to crack one problem at home, you tell me? Just select one problem. I'm not asking you to do all the problems at once, no. Just one problem in lunch hour you do. Take out some 10 minutes from lunch hour. 5 minutes it will take for you to think about the problem. To think about the problem, you don't need to sit and think now. I don't feel like teaching now. You people are not understanding the targets we are keeping. No, we are aiming really high. Look, we are planning homeworks, assignments from such books. We all want you to write your Olympiads as well. Not just advanced, but Olympiads as well. We are targeting Olympiads also. But you people are not serious at all. ఊరికే వచ్చి క్లాస్లో కూర్చుంటే ఏం రాదు కదా. Now what do I do? You tell me what do I? It's only I am doing something every day, and you are all coming in next day, or sometimes someone is coming, someone is not coming. People are not regular. All I'm asking you, all I'm requesting you, is to do the 10-minute exercise and think about the problem when you're free. Free in a sense when you're in the lunch hour, when you're walking towards the college, when you're in the bus, or when you're sitting at the, you're not doing nothing in the class. There is some disturbance in the class. Sir is late. That time also you can think about the problem. And physics doesn't come overnight. You will have to do all these things to do physics. Unless you do it this way, unless you simmer milk, no, you got to heat milk, right? ఆ మీగడ రావడానికి పాలని వేడి చేస్తే మీగడ తొందరగా రాదు కదా. If you want thick cream, you will have to simmer it for a long time. Alani, you will have to simmer your thought process for a long time if you want to get good ideas, which is what you're not understanding. It is not just you open the book, you solve the problem, close the book, it's done. No. And I'm correcting very good problems from all the books. You people are not at all interested in doing any problem. I really don't know what to do. And today who is present, tomorrow will not be present. So I don't understand. Do I wait for that person or do I go ahead with the class? And if because that person loses something, we are targeting advanced ranks. We are targeting really high. Means ఖచ్చితంగా వస్తుంది. Advanced కూడా రావాలని target. Exam రాశారా అందరూ? लिखा सबने exam? Weekend exam have you written?
Yes, sir.
Yes,
Okay,
sir.
Bhavna has written. Likita has written.
Yeah, sir.
Okay. Gayatri, have you written?
Yes, sir.
Harshini, have you written?
Yes, sir.
Okay, I don't see other names, but these are names I'm able to see. A few other names, but I'm able to see those names. So that's. You have got no doubts in the paper? Paper discussion కూడా కాలేదు. ఎందుకు కాలేదు? Because you have not written the exam on Sunday. I did not do the paper discussion on Monday. పేపర్ రాశారు. అడగాలి కదా ఏదైనా డౌట్స్ ఉంటే. You don't have any doubts in the paper? कुछ तो बोलो यार, हाँ ना, कुछ तो बोलो. Don't you have any doubts in the paper?
Yes, sir.
అంటే డౌట్స్ ఉన్నాయా లేవా?
Unde, sir.
So when will you ask me those doubts? This is upsetting students. You're all here because you got selected in a good exam, right? Competitive exam. All right, go for the last question. V naught minus kx. V is equal to V naught minus kx. Solve the problem now. Or help me solve the problem. I'll write the equations you keep telling me. V is equal to V naught minus kx is velocity of the particle traveling along a straight line, where k is a constant. If x is equal to 0, when t equal to 0, determine the position and acceleration of the particle as a function of time. So V is equal to V naught minus k naught x. Is that so? Yeah, right. So if I plot the graph, Vx graph, V naught, tell me the x-intercept of this equation. What is the x-intercept of this equation? Y-intercept is V naught, all right? What is the x-intercept? How do you find the x-intercept?
Sir, x plus mc.
Sorry? Yes, Vignesh?
Can you explain can you ask again, sir? I didn't
Yeah.
understand.
What is the x-intercept? ఈ ఈక్వేషన్ ఇచ్చాను కదా, గ్రాఫ్ ప్లాట్ చేశాను. Y-intercept ఏమో V naught ఉంది. X-intercept ఏంటి? Y-intercept ఎలా తెచ్చాను? X is equal to 0 పెడితే Y-intercept వచ్చింది నాకు. నాకు x-intercept ఎలా వస్తుంది? Y equal to 0 చేస్తా.
Yes, sir.
So V equal to 0
Yes,
చేస్తే what is the x-intercept? Tell me the x-intercept.
K naught.
V naught is a y-intercept. What is
Yes, sir.
x-intercept? I equate V equal to 0. So 0 is equal to V naught minus k naught x.
Yes, sir.
So what is the x-intercept?
So k naught plus v naught.
Look at this. 0
V
is
naught
equal to
K
V
naught
naught minus. So x is equal to V naught by
K naught by K naught.
V naught by k naught.
Right.
Is it okay, Vignesh? Have you got it?
Yeah, sir. Yes.
See, ఇవన్నీ ఇప్పటి వరకు ఫాస్ట్ గా వచ్చేయాలి. Because you have not done the exercise, you have not done the revision, you have not gone through what is gone in class, you have not done the 10-minute exercise, you are unable to think fast. ప్రాబ్లమ్ స్టార్ట్ కూడా కాలేదు ఇంకా, జస్ట్ ఎక్స్ ఇంటర్సెప్ట్ అడిగితేనే మీరు టైం తీసుకుంటున్నారు. ఆల్ రైట్, నో ఇష్యూస్. ప్లీజ్ అండర్స్టాండ్ దట్ ఐమ్ అప్సెట్. ఐమ్ నాట్ యాంగ్రీ, ఐమ్ జస్ట్ అప్సెట్ విత్ యూ ఆల్. All right, now look at this. Why did I draw the dotted line? Because the particle tends to that point but never reaches that point, right?
Yes,
I told you last time. Sorry. Okay, now what I do, I want acceleration as a function of time and velocity as a function of time. That's the question, right? Sorry, position, acceleration, and of the particle as a function of time. So for position, what do? I write v is equal to dx by dt. So I get dx by v naught minus k naught x is equal to dt. I multiply with k naught minus k naught on both sides, and then I integrate. At t equal to 0, position is 0, he said. He starts with x is equal to 0. That's what he said, right? Did he say that? What is the position at t equal to 0?
X equal to 0, sir.
All right. At t equal to t, position is x. All I have to do is standard integral. F dash x by fx is log mod fx. So I'll have log to the base e v naught minus k naught x under limits 0 to x is equal to minus k naught t under limit 0 to t. Alright. Now I substitute x first and then substitute 0. So what do I get? Log to the base e v naught minus k naught x by v naught is equal to minus k naught t. And now by v naught ఎలా వచ్చింది? f of x1 minus f of x2 చేయాలి కదా నేను. Log of a by b ఎలా వచ్చింది? Log a minus log b రావాలి కదా.
Sir.
See, I've got log of this function. No, this function I've got some g of x. I substitute limits x1 and x2. G of x2 minus g of x1 is my should be the limit. Should be the answer. G of x2 minus g of x1. Why? How did I get log of this by this? I should get log of this minus log of something, no?
You have substituted x in the
ఫార్ములా ఉంటుంది
x value,
సార్.
sir.
I substituted x what? Sorry.
V naught minus k naught x ఉంది కదా సార్.
అవును.
అక్కడ x వాల్యూ సబ్స్టిట్యూట్ చేశారు.
అవును. ఫస్ట్ x చేశాను. నెక్స్ట్ ఏం
ఆ,
చేశాను?
దాని తర్వాత x వాల్యూని 0 చేశారు. And
Right.
k naught into 0 it will become 0 and
Right.
remaining the naught.
Okay. Bhavna is saying something. Bhavna, what is that you're saying? What formula you're saying?
So can you please explain from again?
All right. Look at this. Yeah, I'm explaining. Log of this function under limit 0 to x. So what I do, I substitute x first. So I get log of v naught minus k naught x minus log of this under lower limit. Log of v naught minus k into 0. So log of v naught I get. So log a minus log b, I'll get log a by b.
Yes, sir.
So to save space, I've written directly ఇక్కడ రాసేసాను. By v naught అని రాసేసాను. ఇదంతా తీసేసి. Have you got it?
Yes,
Yeah, sir.
sir.
Yes, sir.
Huh. Okay, now I got this function is equal to minus kt. So I will write exponential on both the sides. So I'll get e power one minus k naught by v naught into into x, is equal to e power minus k naught t. So x is equal to v naught by k naught into 1 minus e power minus k naught t. I got x as a function of time. That's what he was asking, right? Look at this. As t tends to infinity, at t equal to 0, what is the value of x? X is 0. But at t tends to infinity, this is becoming 0. E power minus infinity is 0. And I get v naught by k naught. That's what I'm getting here. From the graph as well, I got the same thing. As x to t tends to infinity, x is tending to v naught by k naught. If I plot the graph for this one, I'll have an asymptotic graph because e power minus x is asymptotic graph. So initial velocity is v naught. The slope is such that, slope is v naught. Inclination is such that the slope is v naught. Initial velocity is v naught. V naught is going on decreasing. Particle is eventually stopping but not completely stopping. It's slowing down forever. It is approaching at V0 by K0, but it's never touching V0 by K0. That's why I have a dotted line here. నేను ఇంకా చాలా పెద్ద స్టోరీ ఉంది దీంట్లో. There is a previous advanced problem based on this one, which I'm not talking about now because you people are not ready for the question. If you do that exercise, if you do some homework, you'll be ready mentally. Mental maturity increase అవుతుంది. I'll be able to discuss even more finer points in this question. ఇంకా fine points discuss చేయలేదు. Alright. So I've got x as a function of t this way. Once I get x as a function of t, if I differentiate, I'll get v as a function of t. Now differentiate this function and let me know what is v as a function of t. So x is equal to v0 by k0 into 1 minus e power minus k0 t. I want you to differentiate this function and find v. How do I find v? All I have to do is differentiate. Differentiate చేస్తే ఏమొస్తుంది? So x is equal to v0 by k0 minus v0 by k0 into minus e power minus kt. This is constant. So derivative of constant is 0. This goes away. So I'll have v is equal to derivative of this one. What is derivative of this? Minus v0 by k0 is constant into e power minus k0 t into minus k0. Is my derivative. Chain rule. E power ax. So derivative of e power ax is e power x into a. So k0 gets cancelled out. I'll get v0 into e power minus k0 t. So this is my velocity as a function of time. If I plot this one, how do I get the graph? Right? This is how I get the graph. V0 నుంచి డ్రాప్ అవుతుంది. Alright, so I've got x as a function of t, v as a function of t, I want a as a function of t. What do? I differentiate v now. Differentiate this and tell me what is the acceleration as a function of time. Differentiate this quickly. v0 into e power minus k0 t. All I have to do is differentiate v as a function of t. Differentiate v with respect to t. I'll get a as a function of t. What is it a you're getting? Yes, Divya, what is that question? Sir, I think it's minus v. Why minus v? It is minus into minus, you get plus here. This is minus here, this is minus here. So it becomes plus. So v0 into e power minus kt. And look at the graph as well. I've got positive slope here. So I should get a positive velocity at t equal to 0. At t equal to 0, if I substitute, I get v is equal to v0. That means slope is positive. Intercept is positive. Or it's not negative. Velocity is not negative. Particle is going towards the point, towards positive x-axis. See, velocity is positive here. In the vx graph, in the question, my velocity is positive. It's going towards right. So I get v as positive, not negative. All right, I hope that is clear. I want acceleration now. Quickly tell me the acceleration. Differentiate చేయాలి ఏం లేదు. ఇంకా ఫిజిక్స్ మాట్లాడలేదు మనం ఈ ప్రాబ్లంది. Quick. Okay, I'll do it. V is equal to V naught equal to e power minus k naught t. So acceleration is dv by dt, which is V naught is constant, e power minus k naught t. What is derivative of e power minus k naught t?
V, sir.
Derivative of e power minus k naught t.
minus k naught.
Not
Minus k naught?
e power minus k naught.
Right, thank you. So I get minus k naught, V naught e power minus k naught t. Look at this. Acceleration is what I'm getting is negative. So acceleration time graph plot cheste, I'll have e power minus kt minus e power minus kt. It lost in the acceleration. With a intercept, negative intercept. This is minus k naught, V naught. 0 time t. So acceleration is negative. At t equal to 0, my acceleration is minus k naught, V naught, and it is decreasing exponentially. That's e power minus k naught t. All right. So is that clear? Is the question clear? Okay, go for the third question now. For a particle moving along x-axis, acceleration is given as a is equal to x. Find the position as a function of time. For t equal to 0, x is equal to 1, and v is equal to 1. We can talk for at least 3 hours on this problem, but you people are not ready to listen, so I'm not talking. It's a very important problem in the physics. In kinematics, this is the most important problem. రిపీటెడ్ గా ఈ కాన్సెప్ట్ మీద క్వశ్చన్స్ వస్తాయి. చాలా నేర్చుకోవాలి ఉంది ఈ ప్రాబ్లం లో, చాలా నేర్చుకోవాల్సేది ఉంది. All right, look at the third question. I've got a is equal to x. All right, one thing. What is v as a function of x? I've got v as a function of x. What is a as a function of x in this question itself? What is a as a function of x? Can you tell me what is a as a function of x?
Sir, I can't see your
A
screen, sir.
equal to x, sir. A is
Okay.
equal to
No, in this previous problem I'm talking about. V is equal to v naught minus kx undi kada. What is acceleration as a function of x? I'll write acceleration as v dv by dx. V is v naught minus k naught x into dv by dx anta minus k naught. So that becomes k naught square x minus k naught.
Minus v naught.
Right. So this is my acceleration as a function of x. ఇప్పుడు చూడండి, if I plot a graph for this one, I get a as a function of x ఎలా వస్తుంది? Y is equal to mx minus c వస్తుంది. Negative intercept. So I'll have acceleration like this. So minus k naught v naught. This is v is equal to 0 కదా. V naught by k naught. Acceleration x. Look at this. I have not drawn a dotted line for this one. For a ax graph, I have not drawn a dotted line. I've drawn a straight line. That I'll explain later, only after you have done the homework. Now, ఇప్పుడు ఈ క్వశ్చన్ లో ఏముంది? a is equal to x ఉంది. a is equal to x ఉంది, ఇక్కడ a is equal to x minus constant ఉంది. So what is the difference in between these two questions? Only a constant is a difference. So not much difference. In fact, both are same problems actually. Just కొంచెం limits లో difference ఉంది. Both are exactly the same problem, except that you have got initial acceleration here, x is equal to 0 దగ్గర, అక్కడ x is equal to 0 దగ్గర initial acceleration లేదు. But particle is not at x is equal to 0 initially. It is at x is equal to 1. Where is it? Yeah. It is at x is equal to 1, at t equal to 0. So ఇక్కడ కూడా ఏముంది? Particle, where is the particle at x? Initially, x is equal to 0 ఉంటే there is some acceleration over here. Over there, a is equal to x ఉంది, at x is equal to 1, you have some acceleration. So both are same problems actually. అక్కడ కూడా linear function ఉంది as a function of x, a as a function of x, linear ఉంది. ఇక్కడ కూడా linear ఉంది, a is equal to k naught square x minus k naught v naught. Linear function of x, y is equal to mx plus c. Third problem కూడా linear ఉంది, y is equal to x, a is equal to x ఉంది. So both are actually the same problem. మనం solve చేస్తే, when you solve everything, you'll see the functions are also same. So that's not a new problem. ఒక problem ని explore చేస్తే all such problems become very comfortable for us. కానీ ఒక problem ని మంచిగా explore చేయాలి. ఒక problem ని thoroughly explore చేస్తే 100 problems can become simple for us. Not 100, 10 problems will become very simple for us. So ఒక problem ని మంచిగా explore చేయాలి. We have not explored this problem yet. Completely explore కాలేదు. Alright, ఇంకా ఉంది, దీనిలో మాట్లాడేది ఇంకా ఉంది. We'll talk about it later. But now as of let's go for the third problem. A is equal to x. So my acceleration is varying linearly like this. All right. And where is the particle? Particle is over here. At t equal to 0, particle is at x is equal to 1. So what is the acceleration at that instant? Acceleration is also 1. So what will happen to the particle? Will it go away from origin or towards the origin? Initial velocity kuda 1 undi. That means particle is going towards right. Particle is going towards right. Initial acceleration is 1, which is also towards right, positive. So will the particle go further towards right or will it come towards origin? What will happen to the particle? Particle's velocity is towards right, acceleration is towards right. So will the particle go further or will it come back?
I think it goes further.
Go further, sir.
Yes, it goes further. You are right. Don't hesitate. You're all confident. Be confident. You're all. No, I'm not saying you're wrong. You're right. Only thing is you're not working. All right. So it goes further. Right. Now, what is required ultimately? Position as a function of time. Position కావాలంటే నాకు velocity వచ్చేస్తే దానికి ఇంటిగ్రేట్ చేస్తే పొజిషన్ వచ్చేస్తుంది. Velocity కావాలంటే from acceleration you get velocity. How will I get acceleration? Velocity from acceleration. All right. V dv by dx is equal to x. So v dv x dx, I integrate it. When x is equal to 0, sorry, when x is equal to 1, my velocity is 1. When x is equal to x, my velocity is v. Now I integrate. What do I get? Tell me what do I get? Integrate it. That's it, no? T equal to 0, x is equal to 1, v is equal to 1, right? Integrate change. What is integral x dx? X square by 2. Okay. This is v square by 2. So v square by 2 under limits 1 to v. This is equal to x square by 2 under limits 1 to x. So what do I get? So 2 gets cancelled out. V square minus 1 square is equal to x square minus 1 square. 1 square gets cancelled out. I'll get v is equal to plus or minus x. That means I get
ఇంటిగ్రేషన్
yes.
అర్థం కాదు మీరు చేసాను.
Okay. Integration. Integration formula use chesanu. See, integral x dx is x square by 2 from let's say x1 to x2. Okay, integration మీకు కాలేదు కదా ఇంకా?
Yeah, sir.
Yeah, Divya, you are right. I couldn't see. Divya, you can unmute and speak, right? Because otherwise I'll not get to know whether you are typing or not. I mean, I'll have to focus and see. If you are texting something, that's okay. But you are right. It goes further. All right. So integration లో ఇది జస్ట్ ఫార్ములా యూస్ చేశాను. ఇక్కడ వరకు అయితే అర్థమైంది కదా ఇలా ఇది ఎలా రాశానని?
Yeah, sir.
ఇక్కడ నుంచి ఫార్ములా యూస్ చేశాను. x dx is x square by 2, v dv is v square by 2 under limits v1 to v2, x1 to x2. Sarna.
Okay.
Okay. Then I get v is equal to plus or minus x. But then look at this. I've got velocity x graph చూస్తే ఇదొకటి వచ్చింది, ఇదొకటి వచ్చింది. But I have to select one of these now. To go further, to find out x, I have to select one of these. At x is equal to 1, my velocity set is 1. So I'll select this graph, y is equal to v is equal to x graph. So I'll discard minus 1, minus x, and select y is equal to x. Now what I do, I'll write v is equal to dx by dt. I integrate. x ఇక్కడ తీసుకున్నాను, dt అక్కడ తీసుకెళ్ళాను. Alright, multiplying both sides of dt, divide both sides of x. So at t equal to 0, my x is 1. At t equal to t, my x is x. How do I integrate? What is integral 1 by x dx?
dx minus x.
Sorry?
dx minus x. I mean, నేను సబ్స్టిట్యూట్ చేయలేదు కానీ ఫార్ములా కదా.
Formula. Log mod x
యా
వస్తుంది.
సార్.
ln x వస్తుంది. Alright? ln mod x వస్తుంది. That's okay. You don't know the formula, no? That's okay. So I'll tell you the formula. ఇప్పుడు ఫార్ములా ఏంటి? dx by x కి log mod x, which is equal to t under limits 1 to x. I substitute the upper limit, I substitute the lower limit. So I'll get log x minus log to the base e, log 1 is equal to t. Log 1 is 0, right?
Yes, sir.
So I'll get log e, log to the base e, x is equal to t. T వస్తుందా minus t వస్తుందా? T, right? So x is equal to e power t. So look at the function now. X is equal to e power t వస్తుంది. If I plot x and t graph, at t equal to 0, my x is 1. ఇలా ఇంక్రీజ్ అవుతూ వెళ్ళిపోతుంది. Alright? So I got position as a function of time. Is it okay? ఇది డాటెడ్ వేస్తాను బికాస్ ఇట్స్ పాస్ట్. పాస్ట్ గురించి మనం ఎప్పుడు ఏం మాట్లాడలేదు. పాస్ట్ కూడా మాట్లాడదాం తర్వాత. బట్ యాజ్ ఆఫ్ నౌ మై పార్టికల్ ఫ్యూచర్ ఆఫ్ ద పార్టికల్ ఇస్ ఫ్రమ్ t equal to 0 till t is equal to infinity. Particle is going away from origin, away from point 1, x is equal to 1. Origin నుంచి దూరం వెళ్ళిపోతుంది. I got x as a function of t. What is v as a function of t? I differentiate this. I get v is equal to what is derivative of e power t with respect to t?
et into t, sir.
One
E power t. No, derivative of e power x with respect to x.
e power
Log x.
Okay, these derivatives you have to remember, okay? It is e power t itself. Derivative of e power x is e power x.
yes sir.
Alright, so I get v as a function of t. Acceleration ఎలా వస్తుంది? Acceleration కూడా e power t వస్తుంది. Alright. మీకు డెరివేటివ్స్ అన్ని మళ్ళీ టేబుల్ ఒక ఫార్ములాస్ టేబుల్ ఇవ్వాలంటే ఇస్తాను, బట్ యూ హావ్ టు వన్స్ గో త్రూ అండ్ రిమెంబర్ ఆల్ ద డెరివేటివ్స్.
Okay, sir.
Alright. So now, so there are 4 more problems, I think. Yeah, 4 more problems in this. No, 3 more problems. You try that. You think about it. I am not asking you to solve the complete problem and do it. I just want you to think through and be ready for the discussion in the next class. All right.
Okay, sir.
So, for example, there is another problem homework I gave you. The homework says this. I'll not solve the problem, but I'll just tell you the problem. This is a particle projected velocity v naught under gravity. All right, from ground. If there were no resistance, air resistance, this particle will go up, stop at certain height, and come back. Right? To what height will it go? V square minus u square is 2as u square. V square minus u square is
2s.
2as u square. I'll get v is final velocity 0 minus cancel అయిపోతుంది. X is equal to v naught square by 2g. I get maximum height reaches v naught square by 2g. All right. But now
Yes,
the
sir.
twist is there is a retardation of because of drag force. Air resistance valla, there is a retardation. Drag forces are usually velocity dependent forces. Right? Relative velocity dependent forces. What will drag force do? We'll try to slow down the particle. And the fast because of drag force, it will slow down. So drag force is given as kV. So my acceleration is g minus k naught v. Now the question is, to what height will it go? Obviously, ఆ height కంటే తక్కువనే వెళ్తుంది కదా. V naught square by 2g వరకు వెళ్ళిందంటే without resistance. Resistance వల్ల తగ్గిపోతుంది కదా height.
Yes,
I have to find
sir.
out this height. All right. Understood the question? Particle's velocity is v naught. Initial velocity is v naught. Its acceleration is given as g minus kv. ఎలా వచ్చింది? నాకు drag force ఇచ్చారు. Acceleration retardation because of drag force ఇచ్చారు. Minus kv. Acceleration of gravity is g. But then g is also downward. Minus kv is also downward. So my acceleration is minus g minus kv. You'll see that? Minus g కింద ఉంది. G కింద ఉంది. అందుకే negative g. kv కూడా కింద ఉంది. Drag force is also downward. ఆ ఫోర్స్ వల్ల రిటార్డేషన్ కూడా కిందనే ఉంది. యాక్సిలరేషన్ కిందనే ఉంది. సో రిటార్డ్ అవుతుంది పార్టికల్. సో మైనస్ కేవీ జీ మైనస్ కేవీ. వన్స్ ఐ గెట్ దిస్ యాక్సిలరేషన్ వర్సెస్ ఎనీ ఫంక్షన్, ఒక ఫంక్షన్ వచ్చేస్తే దెన్ ఐ విల్ యూస్ డివి బై డిటి, విడివి డిఎక్స్ యూస్ చేసి ఐ విల్ గెట్ అదర్ ఫంక్షన్స్. నాకు కావాల్సింది మాక్సిమం హైట్. మాక్సిమం హైట్ దగ్గర వాట్ హ్యాపన్స్ ఎట్ మాక్సిమం హైట్? వెలాసిటీ బికమ్స్ 0. Right, it goes up, stops and comes back. So అక్కడ స్టాప్ అయినప్పుడు దట్స్ ద మాక్సిమం హైట్ రీచ్డ్. ఇంకా ముంగట వెళ్ళలేదు. Right, so that's what. Think about the problem. You have to find out the maximum height reached by the particle. All right, this is the homework I've given you day before yesterday. All right, think about the problem. I'm not asking you to solve the complete problem. Think about the problem, how to go about it. దీన్ని యాక్చువల్లీ వచ్చాక ఏం చేయాలి? ఎక్కడెక్కడ లీనియర్ గ్రాఫ్స్ ఉంటే ప్లాట్ చేసేయండి. Graph wherever sketchable, sketch the graph. All right, students, that's all for today. Please do not mind what I said, but do understand what I mean to say. All right, నేను ఏం చెప్దాం అనుకుంటున్నా అది అర్థం చేసుకోండి. So please try to do the homework. Homework you don't have to sit and do everything. You have to think through whenever you are free. You are definitely free in bus. You are definitely free while having lunch. All right, while having any gossip with the friends. You're definitely free that time. You have to think through that time. And 10-minute exercise is very important. You have to think through the problem, any one problem, any good problem, just before you sleep. All right, students, that's all for today. Have a great day.
Thank you, sir.
Thank you, ma'am.
Yes, sir. Thank you, sir. Thank you, students. Now you can join the 6 to 7 session. Join the next link, 6 to 7 session.